From all the presentations we've had so far, we would see that it's a very big problem we face. We've been delivering projects for a long while, projects that we need, critical infrastructure that we need in this country. It's massive, population growing in the major cities, congestion contributing to some of the problems we face, urban sprawl, and we see population growth as well. But how do we then deliver what we need, the infrastructure that we need, in a cost-effective way, in a way that also doesn't rob the future in a way, financially? I'm not going to talk about the causes of cost overrun here, but in a way I'm going to probably draw together all that's been said here, and also just how do we mitigate these problems? How can we get better at delivering projects better? All right, now this would become very familiar now, all right? Articles like this, media posts like this have become very familiar. And this is still ongoing. And we can see the in the highlights underlined there, blown out by, well, 150 million because of complex design at the State Library site. The project is still ongoing, early stages to be finished in 2020. But it's not just an Australian problem, I promise you. All right, it's not just Australia. Folks across the pond also face exactly the same problem. California's high-speed rail, if you follow the news. Now, I lived through this one from construction to delivery when I was in Edinburgh, still studying as a master's student at this time. Yep, it was 3 years late. It was 3 times over budget, leading to a public inquiry about why the project was so over budget and took forever to deliver. The public inquiry is still going on. London Cross Rail has been mentioned already. All right, it was going good, and it was held out as the example of project controls, what we need to do to deliver projects successfully, until very recently when we realized, yeah, maybe not. All is not too well, all doesn't look as well as we've been told so far. Then HS2. Now, if you thought the suburban loop was big and ambitious, think about that. Right from London all the way to the Midlands, in the UK, 56 billion projected. Part of the project has started already, other parts still getting approval as we go. Acquisitions going on, land rights going on at the moment, protests in some places, the green campaigns going, no, we don't want this project. People going, yes, we want this project. But it's a high-speed rail, all right across UK. And that price tag there, that's 100 billion thereabout Aussie dollars. Okay, suburban loop, 50 billion. That's expensive. That's audacious. That's big. That's bold. Boss says, we actually don't even know how much it's going to cost. Because the costs have been going up and the scope has been changing, and we're finding new things as we go along, and we're expanding the scope, rightly so sometimes, because we need to be more innovative as we go along. Stations and that we thought weren't there, now we have them. So things change as we go. The project evolves. Now that call saying that we don't know how much it's going to cost has led to, well, maybe not that alone, but there's a big portfolio of almost 450 billion being spent on infrastructure in the UK. And with cost overruns here and there, they thought we better look into this. So there's an ongoing inquiry at the moment by the MPs to look into the government's management of major infrastructure projects, most of them being transport. I was invited to provide a submission for this inquiry, specifically to deal with cost overruns, but also on the method that the government was using in the Transport Department for evaluating projects on the reference class focus. And Pedram has mentioned that one of the methods that we use to try and de-bias or remove optimism bias and deal with strategic misrepresentation. And I was asked to comment on that and how we might get around that. I call it a clear and present danger to cost-effective capital spending. The link there, you can read the whole article yourself. But it's been a 10-year journey for me looking into this problem of large infrastructure projects, and 10-year journey looking into why it goes wrong so often and what we could do about it. Published quite a lot on this, rethinking cost overrun. That was my thesis some time ago when I did my PhD, dealing with cost overrun, using a systemic view of cost overrun from political contributors to engineering to economics to estimating. How do we use a systemic perspective on this? And very latterly, concentrating on transport infrastructure and publishing in Transport Research Policy and Practice, because that's where I want my research to go, how to influence policy and practice, looking at cost overrun, how we might deal better with the uncertainties that we face when we prepare budgets and business cases. Light rail specifically, again, looking at how we might future-proof budgets and deliver value for money when we deliver projects. And this is the one that got a lot of attention right across academia and partly in industry and the Cost Engineering Society on debunking fake news, when I took a lot of flack. Not flack, but we criticized the reference class forecasting and thought maybe that's not the only way to go. And maybe politics is not the only answer to the solution, or getting politicians out of the room when we make these decisions is probably not the way to go. And so we're looking at a systemic way to deal with the problem. But obviously, that wasn't enough. They wanted more, so they asked us to write more on this. And this was accepted. You can see the date there, just 2 weeks ago. On the planning fallacy, on why we usually assume that everything would go okay, that we're going to spend 50 billion on the suburban loop and we're going to deliver it in 2030. Why we make these assumptions so early when we actually don't have all the details that we need. So that's very handy. If you want a link, I can give you that. But we've published quite a lot. How do we get the best out of this problem, out of delivering the infrastructure we need? But what have I learned on this 10-year journey? And probably would summarize everything that every other speaker has put here. It's a very, very complex problem with several moving parts. It's politics, it's technical, it's engineering, it's social, it's organizational, it's economics, it's contractors having a very small margin to play around with and therefore would find ways to get money down the track. It's the politician announcing projects too early. It's the technical details of, well, we didn't know there was going to be a bridge here. Now we need a bridge. We need to put it in. Or we thought we were going to build this, but actually, while we're here, we better build that, because that's going to be better for the future. It's a lot of things put together. It's a complex web that we need to deal with. And I'm glad that we've got people from business here, people from law, people from construction engineering, transport engineering, everyone here together, because it's a very systemic problem. And so to assume, this is the conclusion I put in the last paper I published. Cost overrun causation in complex environment can only be understood when we look at the problem as a whole system, rather than it's engineering. Let's focus on the estimates, or let's get the politicians out of the room, or it's a whole system with several moving parts, and how can we do that together? So attributing the problem to one aspect or one spectrum, I think maybe it's misguided, I suspect, and very often might lead us to very suboptimal mitigation strategies, I think. Now, what did I tell the UK government on how they might be able to deal with cost overrun? First thing I said was, look, you probably need a very disciplined stage gate system. Right, stage gate systems are not new to us, but a disciplined one might be the one that's new to us. We're very familiar with how to do that. Well, too often projects get approved, sanctioned, even before we know exactly what we're building. As a result, the task of risk management is so poorly done that we carry too much residual risk on the project. That's one aspect of a complex mix. Speed kills a project. Schedule pressure at the front end will set up a project to fail. We found that maybe slowing down at the front end, thinking through things carefully, and maybe making decisions that fail, all right, front-end loading by IP is one of the stage gate systems that we use in industry, particularly in the process industry. Uh, um, and it matches very well with the AAC's cost maturity classifications. At FEL 3, all right, front-end loading 3 thereabout, you probably may have spent 5% of your total project, but that's 5%, and 95% could be saved if you took your time and slowed down. But that leads to the problem we see. You see, the public doesn't necessarily want you to spend 5% and decide that maybe we shouldn't build this project. You'll be crucified as a politician if you said we spent 5% and 5% of a 50 billion project is a whole lot. But if you get to that point and you go, maybe we shouldn't do this project because it doesn't add up, what would we say? They've wasted the money. So we've created a very perverse structure here where people go, well, this is not adding up, but we can't stop now. Because if we do, we spent all this money, and we're going to get a lot of politicians who are going to have a field day with us, the opposition usually. Politics comes in. So we stick with the guns.
East West Wing.
Yes. East West Wing. Yes. Well, there you go. We got so far, and then we can't stop. Yeah. All right. So scope definition and a strong business case, so important, so very important. And I'm not going to spend too much time on that because John later on from IPA would be speaking a bit on that. But also, we're generally very optimistic at the front end. Far too optimistic. Maybe we need to be very realistic, but how do we get a realistic? I've gone from accurate estimating to reliable estimating because I don't think it's possible in a very complex environment to get accurate estimates, reliable ones to guide us with the information we have, maybe better. And it would come if we have contributions from all the different perspectives that we are thinking of here, engineers, the economists, the politicians in the room, everyone making decisions together. But this is the one that guesses. Funding bodies and government typically, public sector, focuses on wanting competitive tenders, competitive bids, i.e. a race to the bottom. Because that's what public procurement says you should do. Largely, yeah, but that creates a problem. You can either want an estimate that is competitive, or you can go for one that is predictable. How you blow up the budget, right? If we increase the budget enough, we fall right in. Or we can go for a competitive bid where we put 10 people in the room, 10 contractors in the room, and we go, yeah, okay, we'll give it to, they suspect we'll give it to the one with close to the lowest, maybe the average thereabouts, so not the highest, and it's a race to the bottom. But how do we find that balance, particularly in public spending, where we are not going for absolute predictability or absolute competitiveness, somewhere in the middle? That's what I think might help. So contractors tell me in my research, winning a tender is very, very easy, but winning at the right price. And we can see how that's playing out on the Sydney Light Rail at the moment. Finally, this is the one that most of us have touched on today. Accurate benchmarking. But how do we do that? And what kind of data do we need? Say, causal data is very important. And Pedro must talk. You look at the data, the information that's coming back, you don't know where the extra funds have gone. And so when you say, let's just get first estimates, finishing estimates, let's do averages and do a distribution of where the next project will fall, it's pointless. It would never happen unless we had the causal data, i.e. at what maturity of scope definition did we actually sanction the project? What contributed to the changes that we had and the variability we found as we went along? There's a lot we need to be able to have a rigorous benchmarking protocol. None of these in themselves is sufficient. All necessary, but none sufficient in themselves. We need all together. And maybe that's the message I would love that we take away. We need all together. Let me just finish now so we can go have some lunch. It's a systemic problem we face. System in the sense that there are several moving parts. It takes several years to get these big projects going, especially if it's a mega project. It takes several years with several players coming into play, sometimes the sponsors change over time, the leadership changes over time. Things evolve as we go. Very often we are integrating most of these projects into live infrastructure. All right, and it becomes very difficult to actually do that, to plan and integrate that. Fortunately, we don't work in a manufacturing industry where we can prototype everything and just no. Lots of moving parts on a mega project, several stakeholders, hundreds coming together, thousands of workers coming together over several years. It's not as easy as we think. And going for the easy explanation of let's blame the politician or let's blame the estimate, very often I think it's much more nuanced than that, I suspect. All right. My key suspects on those that caused overrun, the level of scope definition upon which we sanction the project. If we don't have the details, you've set up yourself to actually fail. And if you sanction too quickly, you're generally going to fail. And if the track record is anything to go by, we know that most projects struggle in terms of cost and most struggle to actually deliver the benefits that are promised. So maybe there's something in there we need to look at carefully. Optimism plays a big part of what we do. I'm Ghanaian from Africa, which means I have a very large dose of optimism naturally, and so I need people to tell me that it's not going to work. And when we come to large projects and we are thinking 5 years, suburban loop, we are talking 2030. How could we know what's going to happen in 5 years, in 10 years? So having a nuanced conversation around where the problems come from, I think would help us better. I would say again, let's slow down the front end. Most projects are set up to fail because the front end has gone wrong. Much like Ben's presentation, not all overruns are bad. Some overruns are not overruns. It's just scope that's grown to do exactly what we proposed to do in the first place. But once we know more, cost grows. It typically doesn't go down. And so when we go, oh, you said 50 billion, but it's now 70 billion, and therefore you've overrun. But no. Maybe we need the context there. Maybe. There's a lot we do not know, and there's a lot we can research together. There's a lot we can work together as an industry, as researchers, and I'm glad that these two different groups are in the room today. What we've been trying to do at Deakin is working in a team of people that have different expertise in transport to look at the problem from a very system perspective. Engineers, economists, business people, construction people, project managers, all coming together in a hub to try and look at some of these problems and how we might be able to deal with it. The status quo is not so great, and we want to partner with industry. We want to partner with everyone out there to solve these problems together. And I'll ask, and I'll do this again later on, first, we want partners to be able to solve the problem because it's not an academic problem, it's an industry problem as well, and we want to be able to do that together. I think I'll leave it there for now. And if anyone has any questions, I'm more than happy to take them.